Integration, Theoretical Expected Examples, Assignment 3. There are some remarks which are very important. First one is, I am repeating some of the remarks. 0 to a f z d z is equal to change this limit from 0 to a to 0 to 2a, I have to divide by 2. So this is 1 over 2 integral sine 0 to 2a f z dz, provided the rule f of 2a minus z should be equal to f of z. And this integration is 0 if f of 2a minus z is equal to negative of f of z. Second, the same integration 0 to a f z dz is equal to 0 if f of a minus z is equal to negative of f of z. For f of 2a minus z equal to negative of f of z, the integration is 0. And for f of a minus z, if it comes equal to negative of f of z, then also this integration is 0. So for both the cases a minus z and 2a minus z, this integral is 0. Next, you must know about even and odd functions. Yes. The integral sign from minus a to a f z dz is equal to twice the integral 0 to a f z dz if f of minus z is equal to f of z, that is, f is even function. And this happens in the case of where you are having cos function, because cos of minus theta is equal to cos theta. So that is an even function. So whenever you find the cos in your integration, that means you can change the limits to 0 to a twice. And this is equal to 0 if f of minus z is equal to negative of f of z, that is, if the function is odd. Then this integration is 0. Now because minus a to a f z dz is equal to twice 0 to a f z dz, provided your function is to be even function. Furthermore, if I need my limits to be 0 to 2a, I have to divide by 2. Yes, so I have divided by 2 and make my limits from 0 to 2a. This 2 is cancelled with this 2 and I get the integration as 0 to 2a f z dz. Fine? I am using this remark in the foregoing example. Now this example is prove that minus pi to pi a cos theta over a plus cos theta d theta is equal to 2 pi a into 1 minus a over square root of a square minus 1, where a is strictly greater than 1. Otherwise, if it is equal to 1, the function is maybe not defined. Now the solution is minus pi to pi a cos theta over a plus cos theta d theta. Because for solving this integration, for solving our steps, I need the limit from 0 to 2 pi, right? I'm having the limits right now minus pi to pi. Is this an even function? Yes, because cos is there. If I put cos of minus theta, right, then this will be equal to cos of theta. That means f of minus theta is equal to f of theta. This is the condition for the function to be an even function. Yes. So this is an even function. So minus pi to pi will be changed to 0 to pi twice. Right? Now to make the limit from 0 to 2 pi, I have to divide by 2. I have to divide this by 2. So this will cancel. So the integration will be as 0 to 2 pi a cos theta over a plus cos theta d theta. Clear? Alright. Now next step is I have to take the real part of this integration. Nothing to do with the denominator, just we have to make changes in the numerator, provided there is no power in the numerator. Now this is equal to the real part of this integral 0 to 2 pi a. Instead of cos theta I am writing e the power iota theta over a plus cos theta d theta. Remember, we do not have to make changes in the denominator, just make changes in the numerator. So if you, what is e the power iota theta? It is cos theta plus iota sine theta. So if you mention here the real part of this integration, that will be your original integration, right? Next step, we have to now evaluate this integration. Fine. Now put e is equal to e the power iota theta, and from here your d theta is equal to dz over iota z. Now this integration will be equal to, I'm going to write here c because this is a complete circle, mod z is equal to 1. This is az over a plus. Now what is the cos theta in terms of z? This is 1 by 2 z plus 1 by z. And instead of d theta, this is dz over iota z. So this is equal to, if you solve this integration, if you solve this denominator, you will get 2a over iota integral z over z square plus 2az plus 1 dz. Taking this to be as your f of z dz, where your function fz is 2a over iota z over z square plus 2az plus 1. Now to find the poles of the function, we have to take the denominator equal to 0. So z square plus 2az, this is the denominator. I am taking this to be equal to 0. This is your quadratic equation, getting your two roots, which is equal to minus a plus minus square root of a square minus 1. Taking one root to be minus a plus square root of a square minus 1, and the other root beta to be equal to minus a minus square root of a square minus 1. Now we have to check which of the pole lies inside the circle. Now if you check the mod of beta, this is equal to, if you take the mod of this will be greater than 1, because it is mentioning that a square is strictly, in the question you will see, it is a is strictly greater than 1. So a square is also strictly greater than 1. Because a is greater than 1, so obviously if you take the mod, this mod beta comes out to be greater than 1. And the product of these two roots is equal to 1. If you take the mod after taking the product, this is equal to 1. And because mod alpha beta is equal to 1, mod beta is greater than 1, then we will realize that mod alpha is strictly less than 1. How? The product is equal to 1. Can I write mod alpha is equal to 1 over mod beta? Yes. And mod beta is because it is strictly greater than 1, its reciprocal will be strictly less than 1, which means mod alpha is less than 1. So, because mod beta is greater than 1, beta lies outside the circle, mod z equal to 1. And because mod alpha is less than 1, that means alpha lies inside the circle. Now finding the residue of the pole which is lying inside the circle, that is, we have to find the residue of fz at alpha, and the formula is limit z tends to alpha, z minus alpha into f of z. So limit z tends to alpha, z minus alpha. What is f of z? This is 2a over iota z over z square plus az plus 1. Limit z tends to alpha, z minus alpha, z over taking 2a by iota outside the limit. Yes, is there any leading coefficient? Yes, 1. Nothing matters. So you write z minus alpha, z minus beta, because alpha, beta are the roots of this quadratic polynomial. This cancelled out, and then you will get, if you put z equal to alpha over here, you get 2a over iota, alpha over alpha minus beta. Now write down the value for alpha, write down the difference of these two roots. calculate the difference of these two roots and you will get finally a iota a over square root of a square minus 1 minus 1. So by Cauchy residue theorem, this integration is equal to integral sine over cfz dz is equal to 2 pi iota, the residue which we have calculated. This is a iota into a over square root of a square minus 1 minus 1. Iota will be minus 1 and I am taking this minus 1 inside the bracket. And this will be 2 pi a, 1 minus a over square root of a square minus 1. Now equating the real parts, see what I have done over here, a into e the power iota theta. I changed that into, I opened this e the power iota theta as cos theta plus iota sine theta. Now taking the real part of this, real part is this. So equating the real parts, 0 to 2 pi integral a cos theta over a plus cos theta d theta is equal to 2 pi a 1 minus a over square root of a square minus 1. Done. Alright. Next example is prove that integral 0 to 2 pi 1 plus 2 cos theta the power n cos of n theta over 3 plus 2 cos theta d theta is equal to 2 pi over square root of 5, 3 minus root 5 the power n, where n is your positive integer. Oh my god, the power n, so many cos inside the integration. No need to worry guys, whatever you are having in the integration, you just have to solve step by step your solution and you will find that solution is so easier. So the first step is, we have to take the real part of this integration. So nothing to do with the denominator and nothing to do with the bracket having the power. We have to just change this. So the real part of 0 to 2 pi 1 plus 2 cos theta the power n over 3 plus 2 cos theta. Now instead of cos n theta I am writing e the power iota n theta. Right? If you check, the real part of this is equal to my original integration. So we will evaluate this integral now, right? Now again, putting z equal to e the power iota theta, d theta is equal to dz over iota z. This integration will become then over c, this is 1 plus 2. Put the value of cos theta in terms of z. This is z plus 1 over z whole power n over 3 plus 2 by 2 z plus 1 over z. These two will cancel out. This is your z and d theta is dz over iota z. This is z the power n actually. Which is equal to, I am taking 1 over iota outside the bracket, integral c, this is 1 plus z plus 1 over z the power n over 3 plus z plus 1 over z. This is dz over z. Further, here there is also z the power n. This, right? Now I am taking the z inside the bracket. So this is z plus z square plus 1 the whole power n. And then solving this denominator, this is z square plus 3z plus 1, and z the power n, this is dz. Now the z in the denominator will be cancelled out with this z, right? So this is equal to, you take this whole as f of z dz, where I have to mention that f of z is equal to 1 over iota z plus z square plus 1 the power n over, z square plus 3z plus 1. Now the poles of this function is given by taking the denominator equal to 0. So z square plus 3z plus 1 is equal to 0. We find that the poles comes out to be z is equal to minus 3 plus minus root 5 over 2. Now taking one of this root to be as alpha, that is minus 3 plus root 5 over 2, and the other one as beta, minus 3 minus root of 5 over 2, and we check that this mod of beta is strictly greater than 1, and because mod of beta is also strictly greater than mod of alpha and their product is also equal to 1, we get mod of alpha to be strictly less than 1. So beta lies outside the circle and alpha lies inside the circle. Let's find out the residue of fz at the pole z equal to alpha. So the formula is limit z tends to alpha, z minus alpha into f of z. Limit z tends to alpha, z minus alpha into, now f of z is z square plus z plus 1 the power n. In the denominator, I'm having this, z square plus 3z plus 1. Leading coefficient is 1, alright. So instead of this quadratic polynomial, I write in factors because alpha and beta are the roots of this quadratic polynomial. So this is simply z minus alpha into z minus beta, their product. So this cancelled out with this, which is equal to limit z tends to alpha, z square plus z plus 1 the power n over iota z minus beta. Putting z equal to alpha over here, so this is alpha square plus 1 over iota alpha minus beta. You just have to open, what is the value for alpha? This minus 3 plus root 5 by 2. Just square this. Alpha square will be 9 plus 5 minus 6 root 5 by 2. 6 root 5 divided by 4. Just square this alpha. Take the sum with alpha plus 1 and find out the difference of these two roots. You will get 1 over root 5 iota 3 minus root 5 the power n. If you solve, you will get this. Finally, your residue. So by Cauchy's residue theorem, we get this integration to be equal to integral fz dz over c, that is equal to 2 pi iota times the calculated residue. And the calculated residue is 1 over root 5 iota 3 minus root 5 the power n. This iota cancelled out with this. So equating the real parts, we get 2 pi 3 minus root 5 by root 5 the power n. Simple, easy, finished. Alright, so guys, next time, the next video, that is this assignment 4, is very, very, very important one. I'm going to solve very important questions which has come in UGC exams and other NET exams as a subjective question. So this is very, very important, right? And do revise all the notes and remarks which I have written or I display on the screen. Very, very important to understand. Thank you guys. All right. Have a blessed day. Bye.